How to evolve your database applications entirely online. Hi everyone, I'm Ludovico Caldara. I'm Senior Principal Product Manager in the Maximum Availability Architecture team. In our team, we traditionally talk about database availability, client connectivity, failovers. We don't often talk about application changes and how to make those application changes inside a database completely online, but we have the solutions for that. So I will start talking about the applications and how we deploy them online. And well, we all know the DevOps principle, a way for the companies to deploy frequently changes and deploy them to production by integrating properly the tests, by building the new versions and retry them in a repeatable way, in a controlled way. The most common implementation of this principle is using the CI/CD pipelines. Those pipelines are very common today. Everything starts with a developer that pulls from a code repository the code that it has to change, and then modify the code, prepare the new application, and push back the code in the code repository. And then automatically there will be build pipelines, integration pipelines that will build the new application version and test it against a segmented environment. And then if the tests are successful, the application is packaged and delivered inside an artifact repository. So the artifact can be a zip file, a container, a VM image. And then when the development is confident that the changes are ready for production, they will trigger another pipeline, the build pipeline or deployment pipeline, that retries the deployment on a copy of the production environment. And if the test is successful, there will be an approval, either manual or automatic, that will trigger the final deployment to production. And the production can be any production environment, either functions or Kubernetes or virtual machines. So we have a solution in our Oracle Cloud, OCI DevOps, that provide all those capabilities integrated in the service. So you don't need to integrate your own CI/CD tools like Jenkins or GitLab. You have all the services there already. If you want to use them, those are ready for on-premises usage or cloud usage. Now, when it comes to deploying the application to production, there are several deployment types. The most common ones are a blue-green deployment or canary deployment, and the rolling deployment that we will see now. That is the most effective to achieve online application deployment. So you start with version 1 of the application, where you have all the containers running the previous version, and there you have the production workload. But then you start introducing a new container with the new version of the application. And you will redirect there only test users that will test the outcome of the deployment of the new version. And if they validate it, then you can redirect the production workload to the new version and gradually have new containers and decommission the old containers of the old version, up to a point where you will have only containers with the new version and no more container using the previous version. So the application, the old one is completely decommissioned and the new one is completely in production. But what happens if the application has some dependencies on stateful resources like a database? What happens if you need to introduce any incompatible schema changes, for example? So a situation where normally you will stop the application, modify the application schema, the database schema, and then restart the application. So we need a few steps for that. The first one is the ability to clone the database so that we can integrate the database itself inside a CI/CD pipeline. So whenever we have a new build process, we will have a new clone of the database against which we can test the changes that we want to apply to the database. And if you use Oracle Autonomous Database as an example, we have APIs for that. So you can use OCI Autonomous Database created from clone, either an OCI command line or the REST API that will copy the production database or your master copy database to the build environment. And then we can use another command, OCI Autonomous Database generate wallet, that will create a wallet on our deployment container, and we will use that wallet to deploy changes to the database, because the wallet contains the certificates to connect to the database, but also the connection strings, so that we have all the information that we need to connect to the database. But then we also need to apply the schema changes. And well, in Oracle, we have different development tools, starting with SQL Developer, that is the traditional user interface, a very nice one where you can apply the changes graphically to the database. Then we have Data Modeler that you can use to build the new models or apply changes to your data model, and ORDS that expose your data through REST APIs, so you can select and you can query and modify the data through REST APIs. But for CI/CD pipelines, the correct tool is SQL, because it is a command line that integrates well with CI/CD pipeline. So it's a command line that replaced SQL Plus. That was the former command line interface for the Oracle database. And SQL has two important integrations for the CI/CD pipelines. The first one is Liquibase. That is the standard de facto for version controlling of database changes. So it provides a way to run statements inside the database in a repeatable way across different clones of the production data. And it has an integration also with the OCI wallet. So we can use SQL and feed it with the OCI wallet, so it will have all the information to connect to the cloned database. Now, if you're not familiar with Liquibase, in Liquibase you can define XML files that contain the change set, that are the changes that we want to apply to the database. Those can be XML files or SQL files directly. And then you can apply those changes by using the command Liquibase update, that in SQL is lb update. You specify the XML files that contains all the executions, and those executions are persistent inside the database. So whenever you try to rerun the controller, the changelog, it will not reapply the changes that have been applied already. And this is why it is really efficient and repeatable for schema changes. And all the changes are versioned inside the database, but of course also the code, you can put the code inside a versioning system like Git. Then once you have the clone operations and you have the deployment operation, we have to put everything inside the pipeline. So the pipeline in this example, we are seeing the build pipeline, so the continuous integration pipeline. They will have an artifact that specifies the path to SQL, because we need SQL inside our building container. And then the first step will be to unzip the SQL zip file so that we can use the executable. And then a little bit oversimplifying here, but we can have a clone command that contains the very same operation that we have seen before for Oracle Autonomous Database if you want to clone an Oracle Autonomous Database. Of course, if you have another Oracle database type, you can use your own cloning solution. It only needs to be repeatable and possibly fast, because otherwise a copy of a very big database will require some time to create your build pipelines. And then once you have the copy, the final command will be the actual execution of the changes by using SQL. And we can see that we specify SQL with cloud config, and we specify the wallet. That is everything you need to specify for SQL to be able to contact the cloned database. But then you need to connect with username and password, or you can use a wallet for that if you want, or other authentication mechanism, and then update the schema itself by running Liquibase update. Then when you run the changes to a schema, you know that the schema is composed by different type of objects. The first one on the bottom side, we have the tables. The tables are stateful, and not only the tables, but also the partitions and the indexes. So whatever is a segment that is stateful is not easy to just throw it away. We need to maintain it. And so we need to make sure that the changes that we apply are compatible with the new changes of the application and also with the old application version. And the stored objects like views, the procedure, and functions, those are stateless. So we could replace them with the new version and just recompile them. But it's not as easy as it seems, because recompiling objects might cause object invalidations that can throw errors to the application, but also applying schema changes to the tables directly can introduce some incompatible table changes, or also table changes that require a full lock of the table. So those are conditions that we want to avoid. So what might be a solution? We have a product that is called as edition-based redefinition that creates editions. Editions are kind of private view that the application has over the schema model. So an application that will access the employees table, for example, will see a version of the employees table, but then we can have another version, another edition, and another version of the application that will see another representation of the employees table. Because in the edition, we do not put tables, but we put editioning views that are a kind of mapping of a view over a table, but it's a special kind of view that can contain the same type of triggers that the table can have, and can do the same types of DML operations that we can do over a table. So from a logical point of view, they are very similar to tables, but actually they reference the base table that we have behind, but the base tables are hidden from the additions. So the applications do not access the tables, the base tables directly, will access only the editioning views and the objects inside a specific edition. So a new edition will inherit all the objects coming from the previous edition. And if we need to do any changes, like changing the definition of an editioning view or an object, we can just replace it in the new edition that is not used yet, and apply all those changes while no applications are connected to the new edition. And then we can do this rolling deployment over the new edition, like we have seen for the application containers. So this enables online application changes, online schema changes inside the database. But then we also need to modify the tables, for example, by adding new columns or dropping columns or modifying the structure of the table. And for all those non-editionable objects, like tables, partition, and indexes, we have quite a few online operations that you can do today in Oracle Database 19c or 21c. There are many online operations that you can do completely transparently for the applications, but they do not cover the full spectrum of the operations that you can do on a table. So you can do, for example, move table, convert a table from non-partition to partitioned. You can rebuild indexes. You can split and merge the partitions, everything online. But other changes, like some special partition changes, or for example, dropping a column from a table, those are not online as is. And that's why we have another feature that is the online table redefinition, that many customers know as DBMS redefinition, because that is the name of the PL/SQL package that you have to use in order to leverage this online table redefinition. So how it works, we start with the original table that we want to redefine, let's say by splitting a column, for example, into two different columns. So, dropping a column in this case, because it's a offline operation normally. So we create the new entering table that will not contain the column that we want to drop. And this table must be completely empty. Then we start the redefinition, and the start of the redefinition will do two things. The first one is tracking all the changes inside the original table into a materialized view log, and at the same time copying the data from the original table to the interim table. So the tracking of the changes in the materialized view log acts like a journal, so that while we redefine the table, the application can still use the original table, and all the modifications will be in a journal that we can later replay to the interim table. But before that, we need to copy the table dependents, because we have created a table without anything, and the copy table dependents will, according to the parameter that we specify, we copy indexes, triggers, constraints, grants, etc. So once we copy all those objects, we can finish the redefinition of the table. That does two things. The first one, it will apply all the deltas from the materialized view log inside the interim table, so that it is up to date with the original table. And then for a very short amount of time, it will lock the original table, because it will need to do the final sync of the final modifications to the original table and to the interim table, and then switch the names. And here we can see that the table that was named original, now it's called interim, and the table that was called interim, now it's called original. And the new transaction will use the new table version. Now we will demonstrate this not by seeing full CI/CD pipelines, but just by demonstrating addition-based redefinition and DBMS redefinition. We will start with an HR schema, the classic one that we provide as a database sample. But instead of having the normal tables, we will have base tables with $0 suffix, and then we will have an addition, and the additioning views will have the traditional names. So we'll have an additioning view employees, for example. And then we will create a new edition where we want to split the phone underscore number column of the employees table into two new columns, country underscore code and phone number. And then we will see that we work with the two editions, and then we can decommission the old edition. Well, meanwhile, there will be an application deployment that we do not see, but when the new edition will be effective, we will drop the old edition, and then we will also use DBMS redefinition to drop the phone underscore number column from the base table. So let's see how it works. So we start with employees that looks like a table, but it's not, that contains phone underscore number column. Actually, it's not a table, it is the additioning view inside the first edition that can have the same triggers and the same operations like a base table. And actually the base table has the very same column definition and has this phone underscore number column. So the additioning view also have the phone underscore number column, and this is the query that we do in the previous version of the application that has all the stored objects inside edition 1. Now we want to split the column phone underscore number into those two different columns, country code and phone number. And for that, we will use Liquibase that has a few files that will first create the new edition, add the new columns, country code and phone number to the base table. We will create a cross edition trigger to exchange the data between the two editions. We'll populate the new columns, and finally we will create the editioning view inside version, the V2 edition. And let's see how SQL CL and Liquibase work together. So I do the update, and the process is very fast. All the SQLs that we have seen have been applied quite quickly. And I can see that the base table now contains the two new columns, but the employees view does not. Why not? Because we are still in the previous edition in this session. So we can still, first we can see that we have the stored objects also for the new edition. But if I query the table with the previous edition using phone underscore number, that still works because we have an editioning view that contains that. But now in a new session, we will use the new edition. And in the new edition, we will see that the employees view has the country code and phone number now, but doesn't have the phone underscore number column anymore. And I will simulate some queries on the new version of the employees edition view. And we simulate some workload there. And we'll try to redefine the base table by dropping the phone underscore number column while we have some activity on the second edition. So in order to drop the column, well, first we will change the default edition to the new one, so we will be able to drop the previous one. Because we are dropping the column, we are introducing an incompatibility with the previous version. Then we drop the cross-edition triggers that we have created previously. And finally, we create the interim table to be used with DBMS redefinition that we will also execute to apply the redefinition of the table without the old phone underscore number column. So we do the same updates, the same changes using liquid-based update inside SQL CL. And here I'm accelerating a little bit, but we'll see at the end that we will have a new, we will see the base table employees $0 that does not contain the phone underscore number anymore. And we'll have also a different layout of the columns. So country code and phone number will be in between the other columns, just like the editioning view. So in the base table, I have the same column structure that I have in the editioning view. Now I can see at the end that because we've dropped the previous edition, I only have stored objects in the new edition. And with that, we have demonstrated that we can apply those changes completely online to the database schema and to the tables by using DBMS redefinition and edition-based redefinition. So you can leverage those features and put your database inside a CI/CD development and leverage the rolling upgrades for your application to have 100% online application upgrade. And I think that's all for me. Thank you very much.